all, welcome to my YouTube channel. My name is Usha and I am a data scientist. Today I will be discussing about how to detect COVID using deep learning technique, that is CNN, convolution neural network, because I am taking the image X-rays. So we know the COVID situation has affected all across the world and there is a need of rapid testing and rapid evaluation of results. So why I took this use case is, we know the blood tests are quite costly and they are charging around 5,000 to 6,000, and also it takes time to finish this process, at least 5 to 6 hours per patient. And from this X-ray we can also detect then how much spread of the coronavirus in the lungs. Here I'll be using Keras and TensorFlow at the back end, and I am going to detect the COVID virus using the deep learning techniques. And we can also segment, we can also use segmentation techniques to find out how much the particular region that is affected. So can you guess anyone which one is a positive COVID and which one is a negative COVID? Can anyone guess? We are showing the two X-rays. One is a positive COVID X-ray and another one is a negative COVID X-ray. So if you guessed, you comment below and let me know. No idea, because I am not a medical expert. I cannot guess which one is a COVID and which one is not a COVID. So that what I am going to do is I am applying the deep learning technique, that is CNN, to detect COVID, which one is a COVID X-ray and which one is a normal X-ray. So for that, first I am opening my command prompt. So I was in C drive. I want to change my directory here because the C drive is having a lot of files. They are messed up with a lot of files here. So I am changing the directory. Okay, I have changed to D drive. So here I have a file called Usha demo, and I am opening my Jupyter notebook. So it is just started opening. Okay, it started. And you can observe there are two folders here. So one is chest COVID X-ray and another one is chest normal X-ray. First we will open chest COVID X-ray. In this we have two files we require from here, that is metadata.csv and another one is images. So these files I have collected from the GitHub, so that I'll show you where I have collected these files. So this is the link that I will give you, this link in the description. And here once you open this GitHub, there are two files we can see. One is a meta.csv and another one is images. So I have downloaded these files from here, and I have unzipped the files and I have taken. And now, so once you have downloaded these files, so let us open what is there in these files. I'll show you meta.csv. This file is containing all the information. There are features of the particular X-ray, features of the data, and there are some features in the data. And let us open this file, that images I am opening. So there are images of COVID positive X-rays. So see, this is the COVID positive image X-ray. And another file I will show you, that is just normal X-ray. In this file we have three folders, that is one is a train, this we are going to take. In this train we have a normal folder and pneumonia folder. This pneumonia folder is not required for us, and I am going to take the normal chest X-ray folder. So this chest normal X-ray folder that I have collected from the Kaggle, that I will also show you where I have collected this. So this is the link that I will give you in the description, and here we can observe there are three categories of images, that is one is normal bacterial pneumonia and viral pneumonia. So from this I am taking the normal X-ray folder, normal X-ray images. So from here I have to extract only the normal X-ray images. So and from here also, from the GitHub also, I have to take the COVID X-ray. I have to extract the COVID X-ray images. So for that, what I am going to do here is, I am just opening the Jupyter notebook now. So here we have a file. Just I will show you. Yeah. So I already prepared a code. I am just opening that. So here, this is my code that I have prepared already, and we will start with this by importing pandas. So I wanted to tell you one thing. I'm going to divide this project into three parts because the data is not already available. In particular, data what we require for building a model. What I am going to do here is I am dividing my video into three parts. One is data preparation, and one is a data preparation, and second one is model building using deep learning technique, CNN, and another one is I am also going to apply the state of art learning techniques, that is transfer learning technique VGG16 and VGG19. So that is why I am going to divide this. This is a lengthy video, so that I am dividing this into three videos. So I will be uploading the series of videos on this project. So now let us get started with the data preparation. And we will start this by importing pandas. So import pandas. So I will tell you later then why I have imported OS and shuttle. First I am importing pandas here. And it is getting executed, and we will first try to parse the file. And first in this test X-ray data set there is a file called metadata CSV. I already shown this. There is a file called meta.csv, right? And let me give the path of this file, and also there is a images file is also there in this test X-ray folder, and here is test X-ray folder and followed by images. And this I have downloaded it from the GitHub. Okay. And now what can I do here is I can read the file using the pandas. And df is equal to pd.read csv file path. So here first I have to give the file path here, create the data for COVID positive X-ray samples. I am going to create the data for COVID positive samples. So here I will tell you the path is equal to chest COVID X-ray, that we have already shown, chest COVID X-ray followed by metadata.csv. And we have another folder also in that path I am taking here, images underscore path, that is equal to chest underscore COVID X-ray followed by images folder. And let's read the file here using pandas. So now let's print how many rows and columns are there in the data. So that I am using df.shape. So if you observe, there we can see there are 354 rows and 28 columns are there in the data. And now let us see how our data looks like. So that I am using df dot head. So let execute. So this is our data which is actually containing meta.csv. So this is here we can see the column called finding. So this is actually a diagnosis column, and after that I am going to do create a folder, that is a target directory folder, where I will extract all the COVID images. And here I am creating a target directory. So this target directory I am creating here. Target directory is equal to data set. So in this data set I am going to extract all my COVID images. So for this here I am taking the path. If not, os.path.exist target directory. That means if not os path, we can take if this target folder does not exist, we can make this folder. It does not exist COVID, that is, it does not exist the target directory folder which we are creating, the data set slash COVID. So it does not exist, then we can make that folder. Now we can print the COVID folder created in data set. So I'm sorry, now I have to execute the above step first. This one I have to execute. The data created. See, COVID folder created in data set. Check the data set folder in that. Let's go to a D drive. See. So there is a data set folder that is created, and which is, let's open, which is an empty folder. This folder is empty. So what we have to do is we have to extract all the images from the COVID X-ray and into this. Now let's go back. Now here what I will do, I will pick the images and I will put that in the COVID folder that we have created. And now let's see how many images we have for that. And how many images we have. For that I am going to iterate the data frame. If the row, that is a column containing, that is I told you already, this is a very important column we have in the metadata set. So finding is equal to COVID-19. That I will show you here, the finding column where you have in this finding column where you have a COVID-19. So that images will be extracted. So those all images will be extracted, and there is another condition we have here, and the row that is view is equal to PA. So here we have to do another task, that is in our data set there are some images has like the front view, and some of the X-ray images has the top view and side view. So we don't need those X-rays. We only need the X-rays those are having front view. So that information is there in another column, that is a view which is equal to a PA. So here PA stands for posterior interior view. It is basically a kind of a front view. So if I see the count now, we can see here, let's execute this. It is getting executed. It is taking time. You understood it? Here I have iterated, and where if finding column is equal to COVID-19 and the row view, column view is equal to PA. So that is 180 is executed. Now the number of images are having in this is 180 images, and we have copied all around 180 images into the new directory. Now we can see the folder it is, whether it is having. I'm going to the directory. Yes. So already we opened, and I'm going to a dataset folder and COVID. See, before we don't have any images. This folder is empty. Now I have extracted all the images from the chest X-ray COVID folder into a new directory, new COVID folder. Now, till now I have only created the COVID data. I just have prepared only the COVID data. And next, my task is I am going to create another folder that is going to be a normal. So I am going to Jupyter again, and here I am going to prepare a normal folder, image folder, and I am extracting all my normal images from the Kaggle. So for this, I am going to take the chest X-ray images that are actually downloaded from the Kaggle. It is just I'll show you here. So as I show you here, chest X-ray folder. From this I am taking the normal X-rays. And now, so in this train we have two folders. I'll show you here in the previous folder. This is normal X-ray. We have in this train folder we have two folders. One is a normal and another is a pneumonia. And we are just taking the normal folder here. Because we have only around 6,000 images in that folder. So if I take all the images from this, my system will hang out. So that I am only taking a few images from this normal folder. For that, I am randomly picking the images from that folder, normal folder. So for that I am using the random module. I am using a random module here, and the Kaggle path I have taken, Kaggle file path. In that just normal X-ray followed by a train, and which is followed by a normal. This is the path which I have already shown you. And next, let's give the normal directory as we have created for a COVID, same like that. And normal directory, that is data set normal target normal directory, that is I have taken target directory, and here I am taking target normal directory. Here I am taking dataset / normal. There I have taken dataset / COVID. So the same code I am here repeating here. If not os.path exists, target normal directory. It does not exist. We are making that a target normal directory by containing these folders, that is dataset / normal. So that let's execute this first and then this. So here we have printed the normal folder created. So before that, what I am doing here is I just show you first. I just show you here. There is a folder which contains the normal. So I'll show you from back. So here we have a data set. We have a data set. In this we have created, the first one is COVID directory, COVID folder, and the next one is normal folder. Let's see, is there any images in this? No. That means this folder is empty. Now we have to extract the images from the just normal X-ray file. And now I I'm going to my Jupyter again. Now see here. So before that, what I'm doing here is I will extract all the names, then I will pick the random images. So first I will pick all the image names. So that is image names is equal to os dot list of directory Kaggle file path. See, Kaggle file path I have already given here. From this folder I am picking the list of names, image names I am going to pick here, and I'm executing it. And image names. See, if you observe, these are all the image names. So this will give me the list of all the images so that are present in the directory. And now what I can do here is I have to do the random shuffling of image names. See, I have to do the random shuffling of image names. So in that list, from that list I have to I have to do the shuffling first, random shuffling, and then I have to pick the random images from the list. Now let's pick the random images. So for that I am writing here, for I in range of, so I am taking 180 here, because I have 180 images of COVID X-rays. So for I in range of 180 images I am taking, and the images path is, and the image name, image underscore name is equal to images underscore name. And each image we are extracting, and image path is equal to os.path join Kaggle file path, which we have already taken, and the image name. And now I am just copying the images using this function. So this we already discussed in COVID X-ray extraction. Target path is equal to os.path join. Here I am taking the target normal directory and image name. And now I am using a function called settle copy to, and I will give this image path and the target path, and I can print. Now I will write here normal images. And now I am going to print all the copying normal images. So let's print. See, these are all copied, and now I have to check whether I have copied all the normal images into the normal folder or not. Let me check the folder. This is normal folder. See, so now our part is done. Only the data preparation is done. Now we have our data set is ready, and so from this I have to go for the model building. So in my next video I will show you then how to build my model using CNN. That is a convolution neural network, and then I'll apply transfer learning techniques VGG 16 and VGG 19. Then I'll keep on uploading series of videos on this. I hope you like this video. Please do share and with your friends, and please click on the bell icon and press all so that you will not miss any knowledge video. And thank you all. Thanks for watching, and happy learning.